Alright, welcome to the part 1 of the first semester review videos. I gave this document out to people before that said Midterm Exam 2010. It was based on the first semester exam that was given here in 2010, but you'll notice I took some problems off, like there's no number 2. But I left the numbers here because I think some people may have been working on the old version, and I tried to leave the numbers the same so they could compare and refer, cross-reference, and that kind of stuff. And then if you have a newly printed version, it says this on it. And what's nice about that is not only you'll have the ones that match me in the video, but also I added some stuff at the end that we are doing now that we weren't doing in 2010. So some things have been changed a little bit. Again, it's mostly the same, so don't worry too much about if you were working on the old one. It's not like you were going down it the wrong path or anything. Okay, so let's get started. I want to make this under 2 hours long this time. Okay, measure of AOC is 38 degrees and ray OC bisects AOB. Find measure angle AOB. Well, there's no picture here, so you kind of have to think about this yourself. So we've got AOC is 38 degrees. Well, the problem is we're talking about OC being a bisector of AOB. So B is like out here because it's a bad picture. That's a huge 38-degree angle. If OC is a bisector of AOB, it means this is the same as this. So this is also 38. Really small 38 there. So find AOB. That's the big thing. That's just be double the 38. So that's 76. Okay. On the diagram, if A is parallel to B and C is parallel to D, find which variables are the same. Well, one thing to do is just start marking in things you know are the same until you find some ones that are marked angles. I could say like 1 is equal to this thing down here. It looks a lot like 3, but it's not really 3. 3 is just that one right there. 1 is congruent to this thing by 2. Oh, 2 supplementary to 1. Is there anything else supplementary to 1? I don't see anything. While I'm doing that, it might be a good idea, just because this is a review document after all, talk about when we were doing these parallels. There were really 3 relationships that kept coming up over and over again in that chapter. AIA corresponding and SSI. SSI is the weird one because those were the supplementary ones. These were the 2 that were congruent. So in here we're looking for congruent ones. So maybe we should be looking for AIAs and corresponding. AIA is the thing that kind of looks like a Z. Right? It makes the angles like that. Corresponding are the ones that are kind of facing the same direction. SSI is not the one we're looking for, probably. I don't know, maybe we are. But those are the ones that were like this, and they weren't congruent, they were supplementary. Okay, so 1 isn't corresponding with anything marked. 1 is 1 AIA with anything marked. Well, 1 would be AIA with this thing down here, or 1 would be AIA on these parallels with this thing over here, not marked. So 1's a dead end. 2, is it corresponding with anything? It will be corresponding with this thing up here at 1, or this thing over here at 6. Oh, hey, wait, that would be congruent to 6. Oh, yeah, look, 2 and 6 are AIA. They make a Z. It's kind of a funny looking Z, but that's what we're talking about. 2 and 6 are AIA angles. I'm going to stop looking right there. Which 2 angles must be equal? 2 and 6. All right, angle K is 12 degrees more than its complement. K and its complement make 90 degrees altogether. So we'll call this one K. There's 90 degrees. This is 12 degrees less. That's one way to do that. And I know that K plus K minus 12 is supposed to be 90. Here, this will save some time. Combine like terms, add 12 to both sides, divide by 2. How'd you like that? I didn't put the answer blank over here. The answer to 4 is 56. Alright. Number 5. In the figure, EGA, which we should mark this, EGA is congruent to CAE. Oh, interesting. Alright, so we have a little isosceles triangle here, EGA. Name a pair of segments that must be congruent. Well, I just said EGA must be the isosceles triangle here. So, isosceles with those 2 angles congruent. That means that EA is congruent to EG. Great. Alright, number 6, the figure. Find the sum of these 3 angles. Well, remember that in any polygon, if you drew a exterior angle at every corner, it wouldn't have to be regular. The sum of all these exterior angles is always 360, no matter how many sides the thing has. So 1 plus 2 plus 3 plus this thing has to be 360. Well, this thing is, whoops, I was thinking 360. This thing is 90, and this thing is 90 out here. So 90 plus 90 plus 1 plus 2 plus 3 has to be 360. I essentially have 180 here in these two, so these three have to add up to 180 also. Yeah, I keep taking these answer blanks off, sorry. I want to look at these later. I'll put them on the right side here because that's what they look like on your paper. Whoops, that's not where number 7 is. See, would it help to have those? All right, 7 goes here and 8 goes here. All right, number 7, segment RS has a length of 36. T is the midpoint of RS. So here we go, RS, this is 36, and T's in the middle. This is 36. P is the midpoint of TS. Well, first of all, before I get too out of it here, that would be 18, right? And P is the midpoint here, so this has to be 9 and 9. Did I skip ahead? I probably did, because those are midpoints. Find the value of x if RP, which is 27, is 4x minus 1. Okay, a little algebra magic here. 4x would have to be 28, so x is 7. Takes me longer to write that than say it. Okay, this next one they talk about pitch. Well, we've never really talked about pitch in our class before, but you can see with what's labeled here what they mean. What is angle 2 here if this is 35 and this is 90? Let's draw this bigger so we can kind of see what's going on here. Really, we care about this angle out here. This is angle 2. This is 90 and this is 35. This is an exterior angle of this triangle, so it's a lot like number 6. If that's 35 and this is a right triangle, this one has to be 55. Or you could do the exterior angle theorem, which I actually like. Angle 2 has to equal 35 plus 90. Either way, you're going to get 125. That ought to add up to 180 with the little angle in there. That's a 55, by the way. Okay. Alright, find the value of x in the pentagon. Again, this is about angle sum. Actually, again, this is the first time we've done it. Of course, you know these are 90. And you know the whole sum of the pentagon has to be 540. Why is it 540, you ask? Well, any polygon is the number of sides, getting ahead of myself, minus 2 times 180, which here would be 540. But you always put the number of sides in here, and you'll get the number of degrees in the whole thing. So I know that 90 plus 90 plus 2x plus x plus 2x equals 540 because we're talking about a pentagon. Combining like terms. Okay, sorry about that. Got interrupted. Where was I? I think I was combining like terms or something. And then subtract 180 on each side, and then divide by 5. So that would be 72. So that's it. You just need to know that x is 72. You don't need to find all those other angles. You could, and it would be a nice check. All these algebra ones, you can usually put stuff back in here and you could check. That would be 72. These would each be 144. Now there's 2 of them here, but I'm running out of space. I'm going to do this. You could check and see that 144 plus 144 plus 72 plus 90 plus 90 is really 540. Great. Okay, help is a parallelogram. Determine the length of the diagonal h to L. Well, the thing about parallelogram, that's the big piece of information there, is that t is a midpoint of both these diagonals, and that's going to be helpful. First of all, 5x minus 3, p to t, is going to equal t to e. Okay, algebra magic time. Subtract 2x on both sides, and add 3 on both sides, then divide by 3. Okay, so I really don't care to figure this out. I don't have to figure this out. I know these are supposed to be equal. If I wanted to check, just like in the one above, I could. This would be 17, and this would be, ooh, good, 17. This then turns out to be 2 times 4 plus 2 is 10, so this better be 10. So the distance from h to L is 20. Does not stand for hypotenuse leg. Okay, my circles aren't going very fast this time. I'm going to fix that. All right. In the overlapping triangles, so there you go, the overlapping triangles, not this one here. TS is parallel to PQ, that's marked. Find the measure of angle P, so I'm concerned about this one up here. Okay, I guess we do have one transversal that connects all that stuff. We have this one here, so I know this is also 66 degrees by AIA. I have a 73 here, I have a 30 here. If this is here we go. In triangle QTS, that's 180 degrees. So 66 and 73, and this little angle down here has to make 180. So I guess that would be 130, 139, 140. Yep. 41 degrees. And AIA here, I needed that for the parallel, so I've used AIA and I've used the triangle sum. I'm going to use triangle sum again to get angle P. So 30 plus 41 plus 66 plus this has to be 180. Oh man, alright, 71 and 66 is 137, so we're talking about 43 degrees up here. Sorry I didn't show much work on there, but I used triangle sum in case you want to study this at home. I used triangle sum for triangle TSQ first. I used AIA to get angle TQP, and then finally I used triangle sum on QP, triangle QPR. Okay. Okay, number 14, in quadrilateral DUCK, I don't know what it looks like at all. Sorry, I can't draw straight lines very well. But the angles go x, 2x, 3x, and 4x. I don't really know much about that other than the fact that it's a quadrilateral, but those are all the 4 angles in a quadrilateral. So they better add up to that whole n minus 2 times 180 business. Or you probably just know this about quadrilaterals by now. That's supposed to be 360 degrees. Oh yeah, I'm glad I drew it because maybe we have some parallels here. So this is 10x, you combine like terms. So again, I can already tell x to be 36, but it's taking me forever to write this slow enough so it looks good. Okay, so that means this angle will be 36. This angle will be 72. This angle will be 108. And this will be the rest. This will be 144. We will have parallel lines whenever we have same side interior angles that are supplementary. Well, we have a set of same side interior angles that are supplementary here, and we have a set of same side supplementary interior angles there. So that's going to force these lines to be parallel. If you look at that closely, I have these lines sort of inside the parallels that are supplementary, and these two are also inside this pair of parallels. So which was which on here? This one was D, and then 2x was U. Okay, so there we go. So what's parallel? DU is parallel to CK, and that's it. That was the question, actually. It wasn't about the x. Given trapezoid with median length of 10, okay, we've been doing this recently. What's x? Well, I know this plus this divided by 2 is this. So I could just say x plus 8 has to be 20, but that'll look funny later. This will make more sense when you look at this later. And then I'll combine some like terms and multiply by 2 at the same time. Subtract 8 on both sides. Divide by 2. Okay. And you can check that, right? And this would be 6, and this would be 14. And is that a nice progression? 6, 10, 14, plus 4, plus 4. Good. 10's right in the middle. E, F, and G, H bisect each other at P. If EP is H, or sorry, EP is 8, PH is 5, and HF is 11, what's the length of GE? This appears like we're talking about EP is, it looks like we're talking about a number line. When you see this problem out of the middle of nowhere on a problem, it's like, okay, we're talking about EF and GH bisecting each other at point P. Oh, right, in fact, sorry, we're not talking about a number line. We have to be talking about this. If they bisect each other, how would you have collinear things bisect each other? That doesn't make sense. Okay, so those things bisect each other. I need more space. Give me a second here. Right. I have no idea really what they look like, other than I know they bisect each other. So this isn't EF, G, H bisect each other. So they cut each other in half like this. Great. At P. EP is 8, PH is 5, and HF, whoa, that's out here. HF is 11. What's the length of GE? GE is this thing out here. Well, if these diagonals bisect each other, we have to be talking about a parallelogram, so that also has to be 11. And that's it. Okay, I'll see you in part 2. Actually, I won't see you. You'll see me. See you later.